Alright, this screencast is for exponential decay and using your calculator to determine half-life. Exponential decay, what we're looking for is a common ratio that is going to be less than 1, and we are always interested in the percent that is left over or what remains. So if we have an example where something is being lost, we need to take that value that is being lost and find the difference between that number and 100. So in this example, it's 90% is what remains because 10% of the value is being lost. So we have this example here from the textbook about anabolic steroid use, and there's the sentence here, and it says 90% of the drug and its byproducts will remain in the body 1 day later, and the initial dose is 100 milligrams of the steroid. So in your calculator, in your y equals rule, you would have 100 because that's the initial dose, and then times, and remember you can use your asterisks or you can use parentheses, and 0.9 because 90% needs to be represented as a decimal, raised to the x. And then we can go ahead, number 1 is make a table, sure. So push second table. And what we're looking at here is a table that starts at 3. So to start the table at 1, I do second table set and push 0 to start my table at 0. And then I'm looking at the initial dose is 100, then I have 90, then I have 81, and I have 90% of whatever I had the day before. I'm not going to worry about making a plot on graph paper. However, I can make a plot based on my y values and my x values if I change the window. My x min can be -1 just so I can see the y-axis, and let's make the maximum 15 days. And sure, we can count by 2. The y min can be 0. And then the maximum, let's make it 120. And then let's count by 10. So if I turn on my stat plot, so second stat plot is on, so we're good to go. Then I push graph, and that is the decay curve for this anabolic steroid use. And if you check it out, even after we went all the way out to 15 days, I'm still not even at 0. So if I look at the table, it will show me how much of the initial dose of that 100 milligrams of the anabolic steroid. If I start my table at 15, then I still have 20.589 milligrams left over, and this is over 2 weeks later. So the y equals rule is what I put in the calculator, and the next equals now rule would be very similar to this. Our factor of multiplication would be 0.9 starting at 100. And then we want to use this rule to determine how much of the steroid would be in our body after half of a day. So that we would do on the home screen, and we have 100 times 0.9 raised to the 0.5, because we're looking to find how much of the steroid after half a day, so 0.5, and we have about 94.86 milligrams of the steroid still in the body. And then the next part is 8.5 days later, so 100 times 0.9 raised to 8.5 will give us 8.5 days later, and that's about 40.83 milligrams of the steroid. Now we are interested in the half-life, and half-life is when we have the half-life is the amount of time it takes for something to be reduced to 1/2 of what it was when we started. So if we started with 100 milligrams of this anabolic steroid, we are looking in our table for when the y column is equal to 50. So clearly 15 days is less than that. So go back and start the table at 0, and taking a look at the table, we're looking for 50. So somewhere in between day 6 and day 7. So in order to figure out exactly what the half-life is, I have to change what my table is counting by. So I'm going to start at the 6 and change, and instead of counting by 1, I will count by 1/10. Go back to the table, and then in between 6.5 days and 6.6 days, I'm getting that much closer to 50 milligrams of that steroid. Now, the problem says estimate to the nearest tenth of a day. So really, it's about 6.5 days, 50.4. But 49.889 is actually closer to 50. So let's see if we can get a little bit closer. Change the window to 6.5, and then instead of counting by 0.1, count by 0.01. Go back to the table. And here we're getting even closer. This is 0.006 units away. This is 0.046 units away from 50. So we're looking at somewhere in between 6.57 days and 6.58 days. So 6.57, and then we can insert a 0 here and go back to the table, and we'll just say that this is as close as we get. So 6.578 days is the half-life of this particular anabolic steroid, of whose name I cannot pronounce.